So, multiple choice questions. Question 1. An aqueous solution contains this much of sodium hydroxide and this much solution. Kw is that pH of solution is. Okay. First thing we're going to have to do is calculate the moles of sodium hydroxide. Mass over the MR, NaOH, and by sodium OH. So it's going to be 23.1, that's the MR of sodium, I'm pretty sure, plus 16 plus 1. That'll give me the moles. So let me actually just work that out before I keep on, talking. 0.0299975. That's the volume, and we need the concentration. Moles is concentration of volume. Concentration of OH minus equals the moles 0.09975 divided by the volume times by 10 to the power minus 3 converted into moles per DM minus cube. So my answer divided by 250 times by 10 to the power minus 3, and I get my answer as 0.3399, and obviously ionic product of water Kw is equal to concentration H plus times by concentration OH minus. Concentration of H plus equals 1.00 times by 10 to the power minus 14 divided by my answer stored in my calculator, 1.00 times by 10 to the power minus 14 divided by my answer, and I get the concentration of H plus ions, but I want the pH. pH is equal to minus a log 10 concentration of H plus. Substitute that into there, minus log 10 of my answer, 13.6. Okay, next one. This one, the answer is C. I'm not fully sure why. I'm going to ask my teacher tomorrow and then maybe make a separate video on it. So I'm going to have to skip this one, guys. Then carry on moving on. Unfortunately, I just don't want to try to explain it. I just don't know what's going on with that question. Question 3, the equation rate law for the reaction of substance P with substance Q are given below. That's the rate equation. Under which one of the following conditions, all at the same temperature, would the rate of reaction be slowest? Now obviously we've got the pH, we want the concentration of H plus ions. So concentration of H plus ions equals what? Well, we know pH equals minus log 10 concentration of H plus ions. H plus ions is equal to 10 to the power minus pH. So it's just going to be 10 to the power. So I'm going to create a separate column now of H plus, just 10 to the power minus pH, 10 to the power minus 0, 1, 10 to the power minus 2, 0.01, 10 to the power minus 3, 1 times 0.001, 1, 2, 3, 10 to the power minus 4, 0.0001, 1, 2, 3, 4, 1 times by 10 to the power minus 4. Now, which one would the rate of reaction be slowest? All I do is substitute this in. So it's going to be P squared times by concentration H plus. So it's just going to be 0.1 squared times by 1. 0.1 squared times by 1. The rate of reaction would be 0.01 times by. In B, it's going to be 1 squared times by 0.01. We obviously don't care about the pH, we just use the well, we do care about the pH because we use it to calculate the concentration of H plus ions, but we don't need it now. 3 squared times by 0.001, 0.009, 1, 2, 3, and then 10 squared times by 0.001, 0.01. So which one would the rate of reaction be slowest? It's going to be C, my answer. And then question 4. I went through this with my teacher and I know how to do it now. The rate equation for the acid catalyzed reaction between iodine and propanol is that. So you can see in the rate equation we've only got concentration H plus ions and propanol. The rate of reaction was measured for a mixture of iodine, propanol, sulfuric acid at pH that. Remember, concentration H plus ions equals 10 to the power minus pH. So therefore, concentration H plus ions equals 10 to the power minus 0.70. And I don't really need to calculate it right now. Let's just carry on reading. In the second mixture, the concentration of sulfuric acid was different, but the concentration of iodine and propanol would change. I don't really care about iodine, it's not in the rate equation, but I know iodine and propanol was unchanged. However, the rate of reaction was a quarter of the original rate. That tells me that we've only got propanol and H plus in the rate equation. If the concentration of propanol stays the same, it's unchanged, the rate of reaction was a quarter of the original rate, so decreased by a factor of 4. There's a quarter. Well, that's going to happen to the concentration of H plus ions. It's going to decrease. We're going to divide it by 4. And that's the only way for the rate of reaction to be quarter of the original rate, because we only got concentration of H plus ions and propanol in the rate equation. So we find out the concentration of H plus ions in this case. This is, before the second mixture, okay, the first mixture. And then all we need to do is quarter original rate times it by 1 over 4. So we need to do 10 to the power minus 0.70 times by 1 over 4. And then I get the concentration H plus ions this from second mixture 0.04988. Keeps going 155787. But it's just keeping my calculator, and therefore to find the pH of second mixture, well, that's the concentration of H plus ions in the second mixture. Therefore the pH, just going to do pH equals minus log 10 concentration of H plus ions, and therefore we just do minus log 10 of my answer, and I get 1.30. That's the end of the multiple choice question. So question 1C. Question 2D. I didn't even get it right, but obviously I didn't know how to do that one, but the correct answer was D then. But forget about that anyway. I'll be going through that in a separate video. C, question 3C, and question 4B. Finally got it correct. Feels pretty good to get it correct. But yeah, question 2, the answer is D. I'm not sure about that. And that's the end of multiple choice questions.